So we were asked to find the derivative of sine of x, and we could use the limit rule in order to find it. So if we input sine of x into our derivative limit as h goes to 0 of f of x plus h minus f of x over h, we get limit as h goes to 0 of sine of x plus h minus sine of x all over h. We know that due to our trig identities, sine of a plus b is sine a cosine b plus cosine a sine b. So that's basically saying that we can just input that and use a as x and b as h. So sine x cosine h plus cosine x sine h minus sine of x all over h is our new, our factored out thing. And then we can take the sine out of sine x cosine h and negative sine x in order to get sine x of cosine h minus 1, and then we'll just leave this as is because currently we can do nothing about it. So we get plus sine h cosine x all over h. And then we can separate these two limits using the additive limit rule. So limit as h goes to 0, sine x of cosine h minus 1 all over h, plus limit as h goes to 0 of sine h over h cosine x. We know that and then with the limit product rule, we can just multiply these two limits. Sine h over h is one of our rules, and that's just one. And then we could just multiply it by cosine x. And then for this, it's sine x multiplied by cosine h minus 1 over h, and that's just 0. So we get sine of x times 0 plus 1 times cosine x, which means that our limit is sine x or derivative of sine of x is cosine of x. And then for our derivative of cosine of x, we get negative sine x using the same method of putting it into our limit rule, our derivative rule of limit as h goes to 0. And then we could use our cosine of a plus b again like we did right over here. We just follow those same steps of factoring out the cosine of x of this, and then leaving this as is, and then taking the limit of both. And now because it's a subtraction, we use the subtraction limit rule. So we get cosine x times 0 because cosine x h over minus 1 over h is 0, and then we get our sine of h over h, which we know is 1, and then sine of x. So it's negative sine of x. And then we can use all of these limits in order to explain our derivative of tan of x. And we can use our we can use our product rule in order to find sine x over cosine of x. So we know that our low derivative of the high minus high derivative of the low all over low squared will find us the derivative of sine x over cosine x, which is also just tan of x. And then we know that our derivative, so low is cosine x, a derivative of the high of sine of x is cosine x, minus high is sine of x, derivative of the low of cosine x is negative sine of x because of all of this. And therefore, if we just plug those two in, we can cosine squared x plus sine squared x equals 1 all over cosine squared x. So 1 over cosine squared x is equal to secant squared x. The derivative of secant x, 1 is 1 over cosine x, so our low is cosine x and our high is 1. Our low is cosine x. Our derivative of our high, 1, is just going to be 0, minus our high, which is 1, and then a derivative of our low is negative sine of x all over cosine squared of x, and that simplifies out to sine x over cosine squared x. And so we can take this out and this out into sine of x over cosine of x multiplied by 1 over cosine of x, and then we get tangent of x times secant of x. And then and then for the derivative of cosecant of x, we have 1 over sine of x. So we take our low, which is sine of x, our derivative of our high, which is 0, minus our high, 1, which is 1, and then derivative of our low, which is cosine of x, all over low squared sine squared x. And then we can simplify that out to negative 1 cosine of x over sine squared of x, and we can take that apart to become negative 1 over sine of x times cosine of x over sine of x, which is just negative cosecant of x times cotangent of x. For derivative of cotangent of x, we got cosine of x over sine of x. This is our low, this is our high. And then we get our low, derivative of our high, sine of x times negative sine of x, minus our high of cosine of x times our derivative of our low, which is going to be cosine of x, all over sine squared x. So we get sine squared x minus cosine squared, negative sine squared x minus cosine squared x, and then all over sine squared x. And then we get negative 1, and we can factor out negative 1 of sine squared x plus cosine squared x all over sine squared x. So negative 1 times 1 all over sine squared x, negative 1 over sine squared x is negative cosecant squared x.